Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to Physics C1 class. Today we will going to start the next chapter, kinematics. The subtopics of this chapter which will be under discussion are distance, displacement, speed, velocity and acceleration. Objectives of current lecture are by the end of the lesson, students will be able to state what is meant by speed and velocity, recall and use average speed is equal to distance traveled divided by time taken, state what is meant by uniform acceleration, and recall and use acceleration is equal to change in velocity divided by time taken, discuss non-uniform acceleration, recall that deceleration is a negative acceleration. In order to achieve the first objective, first we need to understand what is distance and what is displacement. Consider a body, it is moving from point A to point B in this wave path, which is shown by blue line. So it is moving from point A to B in wave form path. Now, what is the distance traveled by this for this body, and what will be the displacement traveled by this body? Distance will be the length of the path followed by the body between the 2 points, and it is shown by the dotted line, the dotted waveform line, which is the length of the path followed by the moving body. It is equal to distance. But displacement will be the straight line distance between the 2 points, and that straight line distance is shown by this red line. So distance is the length of the path followed by a moving body between 2 points, whereas displacement is the shortest straight line distance between the 2 points given by this red line. Distance is a scalar quantity, displacement is a vector quantity. Since displacement is a vector quantity, so we need to specify the direction of the displacement also. In the present case, the direction of the displacement is from the starting point A towards the ending point B, from the initial position A to the final position B. Next, we're going to discuss two examples to see how to calculate distance and displacement. In the first example, we need to identify the path which is equivalent to distance and the path which is equivalent to displacement. The path OABCD is equal to distance, whereas displacement is represented by the straight line OD. This is displacement. Since displacement is a vector quantity, so we need to specify its direction. Its direction is to the right of starting point O. That is from the starting point O to the ending point D. Next example, Ali walked 1 kilometer to the north, then 1 kilometer to the east, and followed by 1 kilometer to the south in 2 hours. What is the distance traveled by Ali and what is his final displacement? Distance is given by the symbol S. Displacement is given by the symbol D. So there are three distances given, three displacement given. So distance is equal to the sum of the three distances, and the values of the distances are 1 kilometer plus 1 kilometer plus 1 kilometer. The answer is 3 kilometers. Now coming to displacement, the value of first displacement is 1 kilometer to the north. Value of the third displacement is 1 kilometer to the south. So the third displacement is in opposite direction to the first. So the opposite displacement will be assigned negative sign. Over here, displacement will be calculated by the formula d1 plus d2 plus d3. So the third displacement is given negative sign, 1 kilometer plus 1 kilometer minus 1 kilometer, because the third displacement is in opposite direction to the first displacement. First displacement is in the direction of north and the third is in the direction of the south, and north and south, they are opposite direction. So the final answer for the displacement is 1 kilometer. When this distance and displacement have same magnitude, Simple, if a body moves in straight line between the 2 points, then the magnitude of distance and displacement will be same. That is, their value will be same. Numerical value will be same. Can distance and displacement of a moving body be zero? Distance of a moving body is never zero, but displacement can be zero. It is zero when the moving body returns to its starting point. For example, suppose a body covers half of the journey in one direction, and it covers the remaining half in opposite direction. Then the displacement will be zero, but distance will not be zero. Suppose that the body is moving from point A towards right, and it covers a distance of 2 meters, and then it returns to the starting point A. Again, it is covering a distance of 2 meters. In this case, distance is equal to sum of the length of these two paths, and their length is 2 meter and 2 meter. So distance will be equal to 2 meter plus 2 meter. Over here we have two distances. Final answer is 4 meter, but displacement is zero because the second displacement is in opposite direction to the first displacement. So displacement will be equal to 2 meter minus 2 meter. Answer is zero. Second case when displacement is zero is when a moving body, it moves in a circular path. So when it is moving in circular path, it starts from a starting point and it returns to the starting point. So the displacement, again there is zero, but distance will be equal to length of this circular path, which is equal to the circumference of the circle 2 pi r. Whereas displacement is zero, the displacement of this half circle is pi r, and displacement of this remaining half is minus pi r, because that is in opposite direction. So you can say that this is in clockwise direction and this is in anti-clockwise direction. So pi r minus pi r becomes zero. So displacement can be zero if the body returns to its starting point, but distance is not equal to zero. Okay, now we're going to do the recap between distance and displacement. Distance is the length of the path followed by the moving body between 2 points, whereas displacement is the shortest straight line distance between the 2 points. Distance do not have any direction. Displacement, it has a direction, and the direction is from the starting point towards the ending point, from initial position to the final position. Distance is a scalar quantity. Displacement is a vector quantity. Both distance and displacement have same unit, and that is SI unit is meter. Distance of a moving body is never zero. Displacement of a moving body can be zero if it returns to its starting point. First example for this was that the body covers half of the journey in one direction and it covers the remaining half in the opposite direction. Or if the body moves in circular path, in both the cases the displacement will be zero but distance will not be zero. Next topic is speed. Speed is rate of distance of a body. It tells us how fast the body is covering the distance in a specific time. So the formula of speed is distance divided by time. Whenever the word rate is being used with any physical quantity, it means that that physical quantity will be divided by time. So distance will be divided by time. And speed is given by the symbol V, distance by S, and time by small t. So distance divided by time is speed. Rate of distance is speed. SI unit for speed is meter per second. Speed is a scalar quantity because it is equivalent to distance over time, and distance is scalar quantity, therefore speed is also scalar quantity. Speed is zero if the body is in the state of rest. If the body is not moving, it is not covering any distance, so then speed is zero. How to calculate speed? We were going to continue the same example which we have discussed before when we were calculating distance and displacement. We're going to see how to calculate average speed in this case. So Ali walked 1 kilometer to the north, then 1 kilometer to the east, and followed by 1 kilometer to the south in 2 hours. What is the distance covered by Ali? What is the final displacement? Calculate the average speed. So distance was calculated by adding the values of the three distances. In displacement, the opposite displacement, uh, the displacement having opposite direction was given negative sign. So the final answer for displacement was 1 kilometer. Average speed is equivalent to total distance divided by total time. So we're going to use the value of total distance, not displacement. So total distance 3 kilometer will be divided by time. Time is 2 hours. So the final answer becomes 3 divided by 2, 1.5 kilometer per hour. So the formula of average speed is total distance over total time. Next, we have to discuss velocity. Speed was rate of distance of a body. Velocity is rate of displacement of a body. That is, displacement is divided by time to calculate velocity. Symbol for speed and velocity is both v. Displacement is given by d and time is t. So the formula is displacement divided by time. SI unit of both speed and velocity is same. It is meter per second. Since velocity is equal to displacement divided by time, displacement is a vector quantity, therefore velocity is also a vector quantity. Velocity is zero if the body is in the state of rest. Just like speed is zero when the body is in the state of rest, therefore velocity is also zero. How to calculate velocity? We're going to continue the same example. In that, we're going to see how to calculate velocity. Velocity is given by displacement over time. This time, we're going to take the value of displacement and that will be divided by time. So displacement was 1 kilometer divided by 2. The answer is 0.5 kilometer per hour. Now, I hope that you know how to calculate distance, displacement, average speed and velocity. When speed and velocity they have same magnitude, if a body moves in a straight line, then speed and velocity they have same magnitude, same value. Similarly, if a body is moving in straight line, distance and displacement they also have same magnitude. Next topic is acceleration. Acceleration is the rate of change in velocity. Change of velocity is also shown by the symbol delta v. In order to calculate change in velocity, we need to subtract two velocities, final velocity minus initial velocity divided by time. Final velocity, that is the ending velocity, is given by the symbol v, and the initial velocity, the starting velocity, is given by the symbol u. So the formula of acceleration is, the symbol used to represent acceleration is small a. Small a is equal to v minus u divided by t. V is the final velocity, u is the initial velocity. SI unit of acceleration is meter per second square. Since acceleration is rate of change in velocity, as velocity is a vector quantity, therefore acceleration is also a vector quantity. Next, we have to discuss when acceleration is zero, when acceleration is positive, and when it is negative. Acceleration is zero when the body is in the state of rest. That is when its velocity is zero. And the second case when acceleration is zero is that when velocity is uniform. So when velocity is uniform, it means that initial velocity and final velocity, they have same value. And when two similar numbers, they are subtracted, answer is zero. So acceleration will be zero. Positive acceleration, if the velocity of the body increases, then its acceleration is said to be positive. And if the velocity of the body decreases, then its acceleration is said to be negative. Direction of positive acceleration is same as that of the direction of velocity or the direction of the moving body, whereas the direction of the negative acceleration is opposite to the direction of velocity or opposite to the direction in which the body is moving. Other name for negative acceleration is deceleration or retardation. Both deceleration or retardation, they are negative acceleration. So acceleration is zero when the body is in the state of rest, or velocity is zero, or when velocity is uniform, again acceleration is zero. If velocity is increasing, acceleration is positive. If velocity is decreasing, then acceleration is negative. How to calculate acceleration? The formula of acceleration is A is equal to V minus U over T. A car is moving with a velocity of 10 meter per second. After 20 seconds, its velocity becomes 50 meter per second. Calculate its acceleration. So first we need to identify what is final velocity, what is initial velocity, and what is time. 10 meter per second is the initial velocity u, and 50 meter per second is the final velocity, and time is 20 seconds. So we're going to substitute the values. V, that is the final velocity, will be replaced by 50 meter per second. Initial velocity will be replaced by 10 meter per second. Time will be replaced by 20. So 50 minus 10 become 40 meter per second divided by 20 second. So the answer is 2 meter per second square. Next example. A bus starts from rest and achieves a velocity of 20 meter per second in 10 seconds. Calculate its acceleration. So the formula of acceleration is A is equal to V minus U over T. We need to identify what is the value of final velocity and what is the value of initial velocity. The bus starts from rest means that initial velocity U is 0. And it achieves a velocity of 20 meter per second means that final velocity is 20 meter per second. Time is 10 seconds. So using the formula, substituting the values, in place of V, 20 is written, in place of U, 0 is written, in place of time, 10 is written. So 20 minus 0 is 20. 20 divided by 10 is 2. 2 meter per second square is the answer. So over here, we are getting positive acceleration. Whenever velocity increases, acceleration is positive. Over here, velocity is increasing. It is increasing from 0 to 20. From 0 to 20. So acceleration is positive in this case, and direction of acceleration will be the same as the direction of velocity. Next example. A car is traveling at a velocity of 30 meter per second. Suddenly comes to halt in 5 seconds. That is, the brakes are applied and it comes to rest. Calculate its acceleration. So over here, initial velocity u is 30 meter per second, but final velocity is 0 because finally it comes to halt, mean it comes to rest. Time is 5 seconds. Using the formula, A is equal to V minus U over T. V final velocity is 0, U initial velocity is 30 divided by 5. 0 minus 30 is minus 30 divided by 5 becomes minus 6 meter per second square. Over here, acceleration is negative. Acceleration is negative whenever the velocity is decreasing. So velocity is decreasing from 30 to 0. The value of velocity is decreasing from 30 to 0. In that case, the acceleration will be negative. Negative acceleration, it has a direction opposite to the direction of velocity. Okay, now we're going to do the recap of speed, velocity, and acceleration. Speed was rate of distance, velocity is rate of displacement, acceleration is rate of change of velocity. Formula for speed is distance divided by time, for velocity, displacement divided by time, and for acceleration, change in velocity is divided by time. Both speed and velocity, they have same unit, meter per second, but the unit of acceleration is meter per second square. Speed is a scalar quantity, but velocity and acceleration, they are both vector quantities. Next, we're going to discuss the term uniform speed. A body is said to have uniform speed if it covers equal distance in equal intervals of time. Over here, you can see that the distance is being increased by equal amount. From 0 to 10, it is increasing by 10 meter. From 10 to 20, again it is increasing by 10 meter. From 20 to 30, it is again increasing by 10 meter. And the time is also increasing by equal amount. So we're going to calculate the speed for different time intervals. And when we calculate, we're going to see that we are getting the same answer. Same answer of speed means that speed is uniform, and this happens when distance is, the body is covering distance equally in equal interval of time. So over here, we will going to see how to calculate velocity for time interval from 0 to 1. So from 0 to 1, we have displacement divided by time. So we have distance divided by time. For speed, distance divided by time, 10 minus 0 over 1 minus 0. So the answer is 10. This calculation shows the speed is again 10 for the time interval 1 to 2. So when time is 2, the distance travel is 20, and for when time is 1, the distance travel is 10. So using the formula, change in distance divided by change in time. So change in distance is 20 minus 10, and change in time is 2 minus 1. Again, the answer is 10. This last calculation show the speed for the time interval from 4 to 5 seconds. So over here, 50 minus 40, that is equal to change in distance divided by change in time. 5 minus 4, again we are getting 10. So a body is said to have uniform speed if the body covers equal distance in equal intervals of time. That is, the distance is increasing by equal amount after each second. So after every second, the distance is increased over here by 10 meter. So in this case, the speed will going to have same value throughout. And if the speed has same value throughout, it is said to be uniform speed. Next is non-uniform speed. A body is said to have non-uniform speed if it does not cover equal distance in equal intervals of time. Over here we can see that when time is 0, distance is 0. When time is 1, distance is 2. When time is 2, distance covered is 6. And when time is 3, distance covered is 14. When time is 4, distance covered is 32. And when time is 5, the distance covered is 62. So distance is not increasing by equal amount. From 0 to 1, it is increasing by 2 meter. From 1 to 2, it is increasing by 4 meter. From 2 to 3 second, it is increasing by 8 meter. From 3 to 4, it is increasing by 18 meter. And from 4 to 5, it is increasing by 30 meter. So the increase in distance is not same. It is not increasing by same value. So when we calculate speed for different time intervals, we will not get the same answer. For example, when we calculate the speed for time interval 0 to 1, over here the formula of speed is change in distance over change in time. So change in distance will be 2 minus 0 over 1 minus 0. Answer is 2. Now we are going to see what is the speed for time interval 1 to 2. So when time is 2, distance is 6, and when time is 1, distance is 2. So change in these two distances is 6 minus 2. Corresponding change in time is 2 minus 1. So answer is 4. Now we can see we are not getting the same answer. So speed is non-uniform. Now we're going to see what is the speed for the last two time intervals from 4 to 5. When time is 5 seconds, the distance traveled is 62. When time is 4 seconds, the distance traveled is 32. So the change in distance is 62 minus 32 divided by 5 minus 4, and the answer is 30. So speed is non-uniform if the body does not cover equal distance in equal intervals of time. That is, the value of speed throughout is not same. Next, we have to discuss variable velocity or non-uniform velocity. Velocity is a vector quantity, so it depends upon both magnitude and direction. It means that it depends upon magnitude of the speed as well as direction of the moving body. So velocity will be variable or it will be non-uniform. That is, it will not going to have the same value. Its value will going to continuously change if only the speed is changing. If only the speed is changing, then the velocity will be variable. For example, a car is moving with the speed of 50 meter per second towards east, comes to rest. So this information tells us that initial speed was 50 and on rest speed becomes 0. So speed has changed. If the speed is changing, then the velocity will be variable. Velocity is also variable if only the direction is changing. For example, a body is moving in circular path. If a body is moving in circular path, the direction of the body is changing at each and every point. So again, the velocity will be variable if the body is moving circular path. Third example, when velocity is variable or when it is non-uniform, it is when both speed and direction are changing. So velocity, variable velocity, it depends upon the magnitude of speed and direction. If one of them change, then the velocity will be variable. If both of them are changing, then again the velocity will be variable. It will be non-uniform. Uniform velocity, if both the speed and direction does not change, then the velocity is uniform. For example, a car moving with the speed of meter per second towards east, it is very clear that the magnitude of speed is not changing. It is 50 meter per second throughout, and the direction is also not changing. It is toward east. So for this example, the velocity is uniform. When a body is moving in circular path, so when it is moving in circular path, the speed is constant. Magnitude of both velocity and acceleration is constant. But direction of both velocity and acceleration is changing, because in circular motion, the direction of the moving body changes at each and every point. So for a body moving in circular path, velocity is variable, it is non-uniform. And for a body moving in circular path, it is said to be accelerating. So when a body is moving in circular path, its speed is constant, and the magnitude of velocity and acceleration is also constant, but the direction of both velocity and acceleration is continuously changing. So if the direction of the velocity is changing, it is non-uniform, it is variable, and the body is said to be accelerating when it is moving in circular paths. Next, we have to discuss uniform acceleration. Acceleration was rate of change in velocity. So uniform acceleration would be the one in which the velocity, the change in velocity, it is equal in equal interval of time. Velocity is changing equally in equal intervals of time. For example, over here, we can see that velocity is changing by equal amount. From 0 to 10, the change is 10. From 10 to 20, the change is again 10. From 20 to 30, again the change is 10. From 30 to 40, the change is again 10. From 40 to 50, the change is again 10. So whenever the velocity of the body, it is changing equally in equal intervals of time, then acceleration will be uniform. If we calculate the value of acceleration for different time intervals, we will get the same value. For example, this is the acceleration calculated for the time interval from 0 to 1. The formula of acceleration is change in velocity over change in time. So change in velocity is 10 minus 0 for the time interval 0 to 1, and the change in time is 1 minus 0. So it becomes 10. Next, we have to see what is the acceleration for the time interval from 4 to 5. So the change in velocity from 4 to 5 is 50 minus 40, and change in time is 5 minus 4. Again, the answer is 10. So a body is said to have uniform acceleration if the change velocity is changing equally in equal intervals of time. Next is non-uniform acceleration. A body is said to have non-uniform acceleration if it does not has equal change in velocity in equal intervals of time. That is, the velocity is not changing equally. Over here we can see that from 0 to 2 the change in velocity is 2, from 2 to 6 the change in velocity is 4, from 6 to 14 the change in velocity is 8, from 14 to 32 the change in velocity is 18, and from 32 to 62 the change in velocity is 30. So the velocity is not changing by equal amount, therefore its acceleration is non-uniform. If we calculate the acceleration, we will not get the same answer throughout. For example, if we calculate the acceleration for the time interval from 1 to 2, the formula of acceleration is change in velocity over change in time. So change in velocity for the time interval 1 to 2 is 6 minus 2. 6 minus 2 over 2 minus 1, answer become 4. For example, the change in velocity for the time interval from 2 to 3 is 14 minus 6 over 3 minus 2, answer is 8. So we are not getting the same acceleration throughout. So over here acceleration is non-uniform. If the body does not have equal changes in velocity in equal intervals of time, then the body is said to have non-uniform acceleration. Over here velocity is not increasing, it is not changing by equal amount after each second. So therefore acceleration in this case is non-uniform. Okay, this table shows the comparison of uniform speed, uniform velocity, uniform acceleration. So if the speed is uniform, it means that the body covers equal distance in equal intervals of time. If the body covers equal displacement in equal intervals of time, then its velocity will be uniform. And if the changes in the velocity uh, of a body is equal in equal interval of time, then the acceleration is uniform. Okay, now the non-uniform speed, a body is said to have non-uniform speed if the body does not cover equal distance in equal intervals of time. Non-uniform velocity, if the body is not covering equal displacement in equal intervals of time, then its velocity will be non-uniform. Velocity is also variable, it is also non-uniform when either the speed is changing or the direction is changing, or both speed and direction are changing, then the velocity will be variable. And velocity will be uniform when both speed and direction they are not changing. Non-uniform acceleration, if the velocity of a body is not changing equally in equal intervals of time, then the acceleration is said to be non-uniform acceleration. That is all. I hope the lecture is clear to everyone.